How's
Hey
it
Lou,
going?
what's up? So what do we have going on here?
So today we're doing testing on our target board system. We designed a miniature SemQuests target board. We call it Gerber SLIM.
Okay.
And what we're doing is temperature testing. So the experiment right now involves heating and cooling our electronics while keeping our system under constant room temperature. So the chamber will cool the electronics all the way down to negative 60 degrees C and see how far we can push our electronic stack. Right now
So it just hit
I'm
negative
just
one.
starting at 0 and I'm going to start going negative.
Okay.
So the target board's set up here. This is the constant in the experiment. I'm not touching it. And our laser with the same power, same beam size, will come out of our collimator, hit the target board, and we'll take a measurement while cooling our electronic stack.
Okay.
So
How many sensors do we have on Gerber SLIM again?
we have about 100 on this little guy.
Okay.
So it's just enough to take a measurement and see basically how our target reacts, the same way as a normal target.
Okay. And then with this laser here, this is our 500 watt laser. Do you know around about the size of the beam that we're focusing on it?
The beam size right now, it's about 2 centimeters.
Okay.
2 centimeters, so I'm hitting about 30 sensors on there with that pitch size, 20 to 30 sensors. So it should give us a pretty good measurement.
Okay. And basically what we're trying to do is we're trying to make temperature correction for our targets so that we can allow ourselves to know what the data on the target should be if the target's operating in an abnormally cold environment, if it's up at a high altitude on an aircraft, or if it's just a really hot sunny day in the desert. So
Correct.
this is part of figuring out more about our targets to make the measurements more precise along the continuum of different temperatures that they might be operating in.
Correct.
You got anything to add to that, Luke?
No, I mean, it's just, our target boards have thermocouple measurements. So even if you engage the target board with really high power, we're going to be able to correct for temperature fluctuations on the target side and on the electronic side. So we're looking to get a more accurate measurement no matter what power you put on target. So.
And I see, looks like here we have our camera trained in on the setup. So this is our control room for our 500 watt laser, so we can stay outside while the laser's being fired. And we have the GUI up for Gerber SLIM. We have the temperature readouts. It looks like the thermal probe is matching the control chamber pretty well because it's coming in at 1 degree C and fluctuating, and our ASIC temperature. So the ASIC is the photo detector that goes onto the target, and it
Shoot the target too.
Oh, you can shoot it real quick. Okay.
So you'll see in the GUI, this is our normal GUI for all of our targets. We have our thermocouple reading for the target I was talking about earlier. Right now we're just about at 0 C with the chamber. And then we're measuring our electronics temperature as well. But I'll go ahead and put the beam on so I can show you. So this is with the beam on, giving our real-time irradiance measurement and power. So basically what I'm looking for is changes in these measurements. They are constant, they should be constant, coming out of the laser, so I'll be able to know what our temperature offsets are for different sides of our targets. So, yeah, that's the experiment, doing temperature testing.
And you just have that tape on the monitor to mark. It looks like it was measuring right up with the centroid bullseye.
Yeah, I'm just marking to see if there's any change in where the target sees the beam on the target. I'm just looking for consistency, you know, because I'm not touching the target board, but if it looks like the beam moved, then I know, you know, something changed, right? And I kind of want to know that.
Gotcha.
But yeah, that's the experiment.
Cool. Thanks, Luke, for telling me about the experiment.
There you go.